Okay, so this is my love child, I guess you'd call it. We're going to talk about green energy today, but in a railroad sense, mostly for motive power reasons. Um, the reasons, top three that they want to get rid of: diesels. They want to start moving away from that. Is the fuel cost, the carbon footprint, and the insurance is too much. We have two options. The obvious option is option one: battery power. Just like a drill, toothbrush, a lot of everyday things use batteries. They just want to make it bigger. And the second option, option two, which is really, really neat because it's the very first of its kind, the only one that I know of, is hydrogen powered. And it's a self-sustaining style of engine. All you have to do is fill it up, and it can go 2,000, 3,000 miles before you have to fill it up again. Okay, battery powered. We have here a drawing by GE, General Electric. General Electric has been building locomotives since the late 30s, and mostly during World War II is when they really started building. Now they're building electric engines, completely electric, no overhead wires, nothing like that. It's completely self-sustained. All you got to do is charge it, just like a phone, only really big. So what we have here is what appears to be a road engine. So road engines have 6 axles. Switch engines and industrial engines have 4. So road engines like this one, there's one made by Norfolk Southern, or for Norfolk Southern, called an SD70E, a special duty model number 70E, electric. And they also have another one called an HH20B, which is a surprise engine for this video because I told you there was one. Let's go over the parts. This big blue thing right here, that's a giant battery, and it's a lot like what you would find in an electric car or lawn equipment. It's all the same kind of battery. And there's new stuff up here. So we'll go from the battery to the AC traction systems converter to these powered axles down here. And what they've got here is a system called B1B. What a B1B is you've got your 3 axles. So B motor, 1 dead axle, and then another B motor. In the rear, same thing, B1B. With these, they've got some new technology now in the safety cabs. In the safety cabs now is something from Wabtec, W-A-B-T-E-C, Wabtec. What they've created is something called PTC, so Positive Train Control. They can stop you when you don't want to be stopped, all the way from the next terminal, however far that is, 100 miles, 200 miles, doesn't matter, they can stop you. If before PTC, it was something called a dead man's pedal. You put your foot on the floor, and until it's like an e-stop. That's basically what it is, an e-stop. So if you lift off that pedal, it would shut everything off. That's really it. So here they see the same thing. They've got this inside the terminal. They've got this big thing that shows their entire district, their system of what they control, and a bunch of red and green lights. They're all signals. and they can see where this engine is at that point in time. As it's moving, what speed it's moving at, what the coupler tension is, so they can tell a lot of things. They can align switches, rip tracks, team tracks, house tracks, all that fun stuff. And the fuel saving, that's really big. Those numbers, it says 10 to 15, but really nowadays, since it's moved ahead a lot, and a bunch of other railroads like Union Pacific, Canadian National, Canadian Pacific, Kansas City Southern's got into it really big. They've actually upped the number from 15 to 25% in fuel saving. All because of this big giant battery. And they're only getting smaller. So they can fit 2 batteries where they had one big one. So they can just flip a switch, and when they run out of power in their battery, they flip a switch, it goes to the next battery. So let's look at something a little different. Both these guys. Hydrogen powered. Yeah. Hydrogen powered. Don't blow yourself up. Okay, so here's that surprise engine. These are actually taking off a lot. It's a household thing from Norfolk Southern. So it's called an HH20B. HH20B. Okay, so like we did with the SD70E. So hydrogen hybrid 20 battery. So remember how I was telling you earlier, road engines have 6 axles. These industrial engines are a little smaller. They don't need that much. So they have 4 axles. But all of them are powered. There's no dead axles. There's no need for a dead axle. It's just extra weight. So these little green dots, they sit above this battery. This battery is made out of nickel metal hydride. These little green dots right here are little tanks. They're little green tanks filled with hydrogen gas. See how explosive this is getting. So what's happening is a chemical reaction, just like a car battery. In an older style car battery or a lawnmower or a marine or what have you, they have these little 6 little tubes, and you fill them with a liquid of some sort, mostly water. Water creates a chemical reaction with the acid inside the battery. Same thing's happening here. It's a self-sustaining battery, so it's constantly charging itself because of these little green tanks. And all of that is going down into this battery. These green tanks and this battery are not the same animal. They are separate systems. One may go into the other, but they are separate systems. Now from the battery, they go here. All these air pumps and lubrication points that it's hitting all the time. So it's auto lube all the time. These little boxes down here, they're getting little dielectric grease in them. It's grease that's infused with copper, little flakes of copper. Looks like glitter on a birthday card or something. But they're all powered, all 4 of them. 1, 2, 3, 4. And they're made different too. These are not like old Barber S2 or Andrew style trucks that have the big flaps with the boxes that you fill them with oil and you close the flap. These are different. These are self-contained. So it's two big bolts that go up, and it holds a big U underneath it. So you can drop 1 axle at a time. But that's a little. This is us over in the States. They don't have this over here where they got this. This is a freight engine. This is something brand new. 2018. This happened in France. It's a commuter train that's capable of 200 miles an hour. And it's also capable of going 2,000 miles on one set. Now when I say set, I mean one charging or one fueling of whatever it is. So this has two systems that mix into a chemical reaction, just like this and just like the car battery. Okay, so straight oxygen, O2, O sub 2, which is straight oxygen. H2, H sub 2, which is straight hydrogen. You put those together, and the chemical reaction from that creates such a current that it has enough power to go to this auxiliary converter, and the traction converter, and the traction motor, while also charging a second set of lithium ion batteries. Lithium ion is kind of familiar, isn't it? Lithium ion you can find in your phone, you can find it in a camera, you can find it in not a flashlight, some flashlights maybe, but you can find it in lawn equipment like Ego or Greenworks or Black & Decker or what have you. Even in a drill like DeWalt or Cobalt. So yeah, that's pretty much it. This is a good option. It could be really catastrophic if it blew up. It wouldn't be like the battery power. That would be a whole nother fire safety system that needs to be made. But that's what I have. Here's some similarities and differences. So both of them have multiple battery packs. So they have a constant stream of power. So both units also carry hydrogen, but they're in exterior fuel cells. That's what the little green tanks were and what the little blue tanks were on top of the iLink. It's called an iLink. It's spelled iLint, but it's iLink. So both axles, both locomotives have 4 powered axles, so they're constantly powered. Unless you hook both of them together, then there's 8 of them. So the differences. What are the differences? Why are they important? So the HH20B gets its power from a generator, while the iLink gets its power from a chemical reaction. So they're really the same thing, but really they're not. So the batteries. Batteries are different. Seems like all we ever hear about nowadays is electric vehicles, trucks, cars. Now there's trains. There's planes too, but I wouldn't fly on a styrofoam plane. So the batteries in an HH20B are, like I said, the nickel metal hydride, and then obviously there's the lithium ion in the iLink. They're both good batteries. One's a little more explosive than the other. One can be tamed a little more. One can be made smaller than the other too. So that's all I have. Here's some references that'll be really helpful if you're interested about this. You can obviously go to these, check these out, little websites. I'll leave them in the comments, description. If you have any questions, put them in the comments and I'll answer them directly. Thank you.